Number one, twosome. This is going to be an interesting one because I haven't done it for a while. I hope I can remember how to do this. We're given an array of integers called nums and a target. Return the indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution. Okay. So we're going to have one solution and you may not use the same element twice. You can return the answer in any order. Okay, so we're getting nums and a target, and we're trying to figure out what indices add up to that. We're going to have a unique solution. One valid answer exists. So target is going to be a number, valid target. So nums is going to be greater than 2. So if we can't find any, then there's going to be a valid solution. So how should we do this? Well, we can brute force it, right? Going through the array once, and then, like, for example, we could have like index 1, index 2 set to 0 and 0. And let's say, how should we do that? Let's say we iterated through the first let's say we iterated through the list, right? And we got the first element. Then we're searching for the difference, right? So let's say the first index, let's say the list was like that, 3, 5, 6, and the target equals the 8. Okay, so we look at the first element, 3, and then we could compare it against the target, right? So target minus 3 equals 5. So we can say, okay, we're looking for the number 5 now. So then we can just, for each element in the list, then we can look for that value. And if we have it, then it's a match, right? So it will be, well, I think the optimal solution is by using a dictionary, and the reason why is because we're going to have constant access regardless of how big the list is. And the key is going to be that number, so 5. This is where I get confused because you're going to store the difference and also you need to store the index. So basically, let's say we go to the first one, it's 3, target minus 3 equals 5. So that's what we're looking for now. So if we have 5, so maybe we could have a dictionary that has like 5 set to the index of that, right? So the index of where we found that first element. So this would be 0 then, right? And then we will put, because dict 8 minus 5 is going to be 3, right? So 3 is going to be something like that. 1. Why do I get 0 again? Okay. So we're getting the difference and we're saying the index where we got that. Okay. So let's try it. Let's have a dictionary called D, and we're gonna iterate through, just in case, I'm gonna do enumerate index and the num in nums. Okay, so yeah, because we want the index anyway. So we're gonna say, let's get the difference first. Difference equals target minus num. Okay, and maybe, well, when we saw that previous example, it was 8 minus 3, so we're looking for 5, right? So we're looking to see if 5 is in the dictionary. So let's say if difference not in the dictionary, then we'll store that difference. So difference was 5, right? 8 minus 3 equals 5. So that's going to be dictionary difference. 5 is going to equal the index at where we're at right now, because the number that gave us that difference is that index, right? So how should I put this? So where do we store that? So found index. So this target is 8 and the blah blah blah. So for here, for example, 9 minus 2 equals 7, right? So we have 7 stored. So we have D7 stored with index 0, right? And then the next one would be D of 2 equals 1. So how do you keep track of the target? That else, if we find it, then we can pretty much return the index and the diff, something like that. I hope that, so for example, we had the difference between 9 and 2 is 7, so we're going to have, okay, the difference and the index, right? And we're going to say else, let's say the S representing the sum would be the difference if it's in there. Actually, not that. It would be num right now plus the difference. If S equals target, then we return something like that. So we got the difference, 9 and 2, we got 7. So cool, we have 7. And by the way, difference is not in dictionary yet. So 7 has not been in the dictionary, so we'll set that index to that. And then we'll say, okay, we're on to the next number. 2. What's 9 minus 7? That's 2. Right? So we're going to say, oh, okay. We're going to put the num in there. Okay, we're going to put the num in there. And the reason why is because we're going to look for 2. So let's do this again. So if we start with 2, right? 9 minus 2 is 7. The difference of 7 is not in the dictionary. So we're going to say, okay, let's store 2 in the dictionary and the index of where it's at. Next, we're going to go to 7. 9 minus 7 equals 2. If the dictionary is, if the key is in the dictionary, then we check. Okay, so 7 plus num plus, yeah, we check the number plus the difference. So 7 plus 2 equals 9. Is that too obvious? And 7, yeah, wait. Oh, we get the index of that plus that. Let's try it. Sorry. Oh, this is tricky actually. It's not an easy problem. Yeah, I got it wrong. Yeah, this is not an easy problem. I did this back in July. This was not easy. So I don't want to underestimate this. Let's think it out. Yeah, let's think it out. So for example, this example, we want, the target is 9. What gives us 9? Well, it's 0 and 2 here, right? Nothing else is going to give us 9. So we go to the first one, negative 10. We get the difference between the target, which is negative 1. So negative 1 is not in the dictionary. So we are going to for index num and enumerate nums, for target minus num equals negative 1. And then how we know that's what we're looking for is, well, 19 minus 9 equals 10. So we wouldn't really know that was that. How else would we know? Well, let's think about it. You're looking for a specific combination there. We check the first number, get the difference. If the difference is in the dictionary, that means we have access to the index. If the difference is not in the dictionary, that means we should store the if the difference is not in the dictionary. So again, if the difference is in the dictionary, then we know what number we're looking for specifically. So vice versa, if we knew the difference between them, we're looking for this. So we want to store the current number and give its index if it's not in the dictionary, right? So if the difference is not in the dictionary, it's not there. So we're going to store the current number. So number index, so that later on it can search for the difference. Otherwise, else if it found the difference, then we're going to say return a list of the index and difference. Yeah, I keep getting caught up on that. I wonder why. Let's see. Let's think about it more. So the difference between 9 and 10 is negative 1, right? So negative 1 is what we're looking for. In a way. So negative 1 is not in the dictionary. So we add it, right? Let's say d of negative 10 equals 0, right? D of negative 10, 0. Let me just write this down. Then we go to the next number. The difference is going to be 2. By the way, 9 minus negative 10 is going to be 19. Okay, so we have 9 minus 7, which would be 2. So we'll say the difference of 2 equals 1, right? Because if you're looking for the difference of 2, it's going to be there. Again, the third element is going to be 9 minus 19. So that's going to be negative 10. And by the way, I'm sorry, I'm supposed to store that number, right? So again, if we go to the first number, the difference is 9 minus, yeah, it gives me 19, doesn't it? But that doesn't matter because we're putting in the number anyway. So 9 minus 9 minus negative 10 is 19. 19 is not in the dictionary, so we're going to store the number. So d negative 10 equals index. Next one, 9 minus 7 is 2. 2 is not an index, so we're going to say 7 equals 1. Then we're going to say 9 minus 19 is negative 10. Else, negative 10, right? D negative 10 else. And then we have that plus num. If num plus, copy that. Num plus the difference equals target. Then we'll return that. I wonder if there's an else. So from here, we say 9 minus 19 is negative 10. Negative 10 is in the dictionary. And we say, okay, check negative 10. That's 0, right? So let me actually 0 and 19, 0 for that, and then 0, 1, 2. This is the second index. So we're going to return 2, but for some reason it's giving me 1 and 0. So anyway, let's do this again. So 9 minus 19, negative 10. Negative 10 is there, so we're not going to store the key, except we're going to return 0, 1, 2, and 0. So I don't know why. I don't know why I'm missing that. Okay. I mean, the cool thing is I was able to sort of figure it out. Like when I first did this, I was not able to problem solve through this. So it took me more time than probably most people, but it was really neat to sort of work this through. This idea that if you have the target and you get the difference between them, then you want to find that target, right? You want to find that number. So you want to store the current number and index, because later on when you get to that number and you subtract that from the difference, it's going to look for that difference. So it's going to look for you. You're pretty much saving your number if the difference isn't already there. Because when you get to that last number, you're going to be like, oh, we've seen that number before. We've seen the difference. So because we've seen it, we're just going to return the value to that. And that's instant access. So at most, worst case, we're going to have to look at all the elements. So that's big O of n. But in terms of retrieving the values and because we're sort of memoizing things we've seen before. Memoization, right? We're seeing the numbers we've seen before. So yeah, cool.